Hey y'all, here's the answer to homework 1, problem number 1, Romer's great-great-great-great-granddaughter on Mars. Alright, Mars is significantly farther away from the sun than the Earth is. Alright, so we're doing the same problem again, except this time we have a much greater radius from the sun that we're going to have to take into account. So we know that the speed of light is equal to 2.99 times 10 to the 8th meters per second. All right. We also know that the distance, the total distance, all right, if we want this entire diameter of Mars's orbits, we were told that the radius is equal to 228 million kilometers. 228 million kilometers would be times 10 to the 8th, but that's still in kilometers, so we want to make sure we turn this into meters. So let's add another 3 up here to make it times 10 to the 9th meters. And then, of course, moving over to scientific notation, boop, boop, let's add 2 more. So our final answer should be that our radius, sorry, I didn't mean to erase that, our radius of the orbit of Mars should be 2.28 times 10 to the 11th meters. All right, and all we're searching for is time. So all we've got is the standard equation velocity equals distance over time. We know velocity, we know distance, we're looking for time. Let's rearrange this equation to make it time equals distance over c, the speed of light in this case, all right, which is going to be equal to this total distance. Remember, we need to multiply it by 2 because we don't want just the radius, we want the full diameter. So that is going to give us, if I erase this a little bit, all right, that's going to give us 4.56 times 10 to the 11th meters, twice this number, all right, divided by the speed of light, 2.99 times 10 to the 8th, all right, meters per second. And if you do the math on that, you wind up with 1525, so 1,525 seconds. We'd like to have this in terms of minutes instead of seconds, so let's divide by 60. Then if we divide by 60, then we wind up with 25.4 minutes. And that should be your answer for the total max and min time difference. All right, but that's the total difference between the closest point and the farthest point. All right, so again, if we want to talk about, what is the difference between when Mars is closest away and farthest away, that total time is 25.4 minutes, which means that an actual max or minimum time would be half of that. 25.4 divided by 2 would give you 12.7 minutes of difference. So when Mars is closest to Jupiter, the eclipse would happen 12.4 minutes faster, and when it's farthest away from Jupiter, it would happen 12.7 minutes longer. All right.